Morning, folks. Here we go. Tuesday. Last day notes for this chapter for us. Don't forget tomorrow we'll have different sessions for talking through stuff. If you need those or if you want to swing by, you're more than welcome to. Today we're going to talk signs and tension. So you've probably seen whether temporary, or full-time traffic lights hanging from a sign. The kind of crazy thing about them is that if you are driving through a construction area where they're working on those, either like a bridge or something like that, they sometimes will put these up just to monitor the flow of traffic. Okay, so that's what we're talking about today. Your Unit 5 in-class review should be available today for you. That's due Friday along with the homework for Chapter 5. And don't forget your test is Thursday and Friday as well. We'll be meeting right away at the beginning of class for those of us who have class on Thursday and those of us who have class on Friday. We'll meet right away and turn you loose and let you go work on tests after that point. Okay, so here we go. All right. So when we look at a 1,000 Newton sign, right? So we're going to say it's hanging from a wire as shown below. So what we want to do is we want to find the tension on the wire. So if that 1,000 Newton is just hanging by a single wire, then what we're going to see is there is a 1,000 Newton force downwards on it, right? Now, the temptation becomes for us to go back and find that F of T equals MA minus MG, right? And you can do that if you want, but I'm not going to encourage you at all to do that. There's an easier way. If we know the weight of it going downwards, then we also know the normal force kind of pulling back up on it. That normal force is just going to be the tension of the wire for us. So what we see, because it's not accelerating, the total upwards force must also be 1,000 newtons. Okay? Because all of that force is just on that one wire. So because this thing is right here, this wire is right here, all that is that's where all that force is going to be for us. Okay? Now, notice, if we put two wires instead of one, with two wires, what we start to see is that the sign is supported here and also here, right? So if it still weighs 1,000 newtons, right, and that 1,000 newtons is still going downwards, what we end up seeing is this is going to get split in two. They're both vertical, and what we should see is 500 newtons for each wire on this side. Okay. Now, the difference becomes this. Notice we still have two wires, right? We got a black wire, we got a white wire. But now we put them at an angle. Because we put them at an angle, what ends up happening is some of this changes. So our downward force here is still 1,000 newtons, right? So the difference becomes this angle for us, right? Now, I don't know if you've ever, put up a picture or a painting or anything that has like a wire on the back of it. But what we see is that the tension on the wire is actually can become more and more and more the larger that angle becomes. So right now at 120 degrees, if we were to try and up that to even more, it becomes really, 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 really filled with tension if all of a sudden we start to add more and more, right? So for us now, this angle adds to it, right? So now what we're seeing is that this wire is going to have two components to it, right? Because if we look at it as a force vector, it's going to have a part of it that wants to go upwards. It's also a part of it that's going to want to go sideways, right? So if we break that into the concept of a vector, which has, strength and direction to it, this one would have an X and a Y component to it, right? Now, this means that the wire has a horizontal and vertical component, just like we talked about. Now, when we look at these two, though, which component of it matters for us? It's only the vertical component that is going to be supporting the weight. Because as we look here, that horizontal, it's not going to add anything to the weight. Now, if we got some wind sway, yes, that's where it comes into play. But for us, only the vertical component of this is the part that we necessarily care about. All right. Because of that, we can figure out how much of that vertical is there. All right. So we know that the vertical pulls up with an upward force of 1,000. Since this is arranged symmetrically, we know that the vertical component of each one is 500 newtons. Now, what that means is that each one of these wires, if we were to pull them even out to the side here, or the side over here, right, are still going to just support 500 newtons, meaning that's all they have to max out at, right? If the sign is uniform, if the sign is, if those wires are connected symmetrically, then we should be okay for that, right? So what we're able to say is, all right, if we only worry about this side of it, meaning this wire on this side, then what we can do is we can take that total downward force, that total 1,000 newtons downwards, and we can split it. All right. By us splitting it, what we see is that the upward component of it is 500. There's the horizontal component. We don't necessarily care about that one, right? So what we want to find is we want to find this tension right here, okay? So if we know this is 60-degree angles because we split that angle in half, right? Now, if that angle were 100 degrees, right, this would be 50. If it were 160, this angle would be 30, okay? So what we begin to see here now is that we can find the tension. Now, the formula we're going to use is just a simple geometry equation, right? Because we want to find that force of tension there, what we're going to do is basically look at this and say, okay, our angle's here. I know I have a 500 newtons there. I want to find my force of tension there. So if I look at this as my right triangle, I can see there's my right angle there, right? So then this becomes my hypotenuse, right? According to the angle, that's my opposite. And then this side here is my adjacent. Because now I can see that I have opposite and adjacent sides, I can use my cosine, right? Ka. So you're looking at SOHCAHTOA, right? So when we have ka, we're going to use adjacent over hypotenuse, right? So there's my adjacent, there's my hypotenuse, right? With my angle there, then what I'm able to see is I can use that cosine like that. So rearrange it a little bit. So what I did there was I just multiplied each side by the force of tension, right? And then divided by the cosine of 60. Again, I can look at that and say this is over 1, cross multiply, divide, right? So 500 times 1 divided by cosine of 60. Well, the cosine of 60, if you plug that into a calculator, cosine of 60 is going to be a half, right? So 500 divided by 0.5, we see our tension is 1,000 newtons on that wire. Now, does that mean that every single time we have this, that the force vertical is going to get doubled so that it turns into the tension? No, not in the least. Okay? All right. A little different variation now. All right. Notice in this one, we said, okay, we've got our kind of horizontal and that we're 45 degrees with respect to the horizontal. Okay. We still got our 1,000 Newton object there. All right. So what happens here is we start to look and say, okay, if we've got 1,000 newtons going downwards, that means each one of these vertical components here, right, is going to contain 500. Okay. So because we know that angle is 45, if we look at just the left component, what we're going to see is this angle here, because it's vertical, because it's perpendicular to the horizontal, that means that this whole entire angle here has to be 90 degrees, right? Once we see that, it becomes easy. Make it our right triangle again. Well, if we know that this is 45 here, 45 plus what equals 90? That's going to be our other 45. That's how we get that one. So if this angle would have been a 30-degree angle down here, right? And that would have made that a 60-degree angle up there. Okay? So once again, we just want to find the tension in that cable. Because we know that this thing is a right triangle, because we're able to figure that out, what we're able to do is say, okay, this angle here, that's our hypotenuse yet. This is our adjacent, right? So what we end up running is our cosine of 45, okay? So then our tension is equal to 500 divided by the cosine of 45. Cosine of 45 is 0.707. So 500 divided by 0.707, right? 500 divided by that, we get 707.1 newtons of force, or newtons of, tension on that wire, all right? So last little variation. We now ask what's different here, right? So instead of the angle being way down here, right, now we put it up there. So when we look at this, then we say, all right, the thing that changes here is if this is still a right triangle, all the internal angles have to add up to 180 degrees. Now, I don't remember what that rule is called, all right? And I didn't get a chance to reach out to our geometry teachers to ask them. But what I know is that because this thing is a 90-degree angle here, that means that these two angles, this one and this one, have to add up to 90 as well, right? So this thing then has to be a 45-degree angle. With that in mind, that allows us then to say, oh, all right, well, if this is 1,000 down, then that means there's 500 for each of the vertical components. There's 500 for each of those vertical components of this wire and this wire. So now I can figure out the tension on that wire based on the angle being here and this being 500. Okay? Give section 4 homework a shot. Sorry, I got one more. I forgot. All right. To make your life as easy as possible, here's what I basically came up with. If you can get this angle down here, so the angle right in the inside of this here, all right, if you can get that angle, that goes for this theta right here, all right? Now, if you can figure out, if they tell you, hey, this is 1,000 newtons down, then we know that's 1,000 newtons up. So if we take half of that, that goes right there. That's our, again, remember, that is our adjacent side, right? The tension, that's our hypotenuse, right? Which is right there. Okay? So once we know that angle, what we can do is we can figure out, okay, what's the tension on that string? All right? Check out section 5 for homework. It should not take you very long to finish that one up. I think it's a couple problems for a section. And then start cracking on the in-class review. That is your goal for tomorrow, is to work through that in-class review. If you have questions at all about it, I'll make sure I get a walkthrough out there over the course of the next couple days. Okay? Otherwise, take care, and we'll see you on the other side. Bye-bye.